Hello guys, welcome back to the new video. So in this video we will look into that keeping API key at a secure place, clean architecture, dependency injection and that image preview. So first thing, let's go to our constant file. As of now we are keeping our API key in the constant file. But keeping API keys in a constant file within your app source code is risky and can lead to unauthorized access to our services. If the key is in our codebase, anyone with access can see it, and even hidden keys can be extracted from the compiled app, or accidentally pushing your code to the public repository like GitHub can expose the keys to the public. Even if you remove the keys later, they can still be found in the version control history. One way to manage API keys more securely in an Android project is to use the build.gradle file to define keys and access them via build config. Let's cut this API key from here and go to this build script, and here we have this file local.properties. So here we can keep our API key. Now next thing, we need to make sure that this file don't go to that version control. For that, here let's go to this project directory and we have this git.ignore file. So here we specify all those files which we don't want to go to that public repository. So here we have already specified that this file should not go to that GitHub repository. So let's close this and go back to our Android directory. Now next thing, how we can access this API key in our app. So first thing, we need to go to this module level build.gradle, and here in this default config block, after this we will specify, first thing we need to create the value of this properties. So here this java.util. Now with the help of this properties value, we have this function load. So here let's specify our file. So this is how we specify the file. So here we are saying that we need to go to this project directory, then this root project, and there we will have this file with the name of this local.property, and then we will get the input stream of that file. Now let's define our build config field. So here we need to provide these three things. First thing, type will be the string and the name will be the Unsplash API key. So here with the help of this properties, we are getting this property. Let's make sure that the name is correctly. So here, let's copy it and paste it here and here also. So here we have defined our build config field. So now let's sync our Gradle file. So here it has been synced. So let's close this and this one also. Here we need to make the reference of this API key. So here let's use this build config. Right now we can see that it is not accessing that build config field. For this thing we need to first build our project. Let's just rebuild our project. It is showing error. It is saying that we need to add this build config to true. So let's go back to our build.gradle file, and here we have this build feature block. Here we can say build config to true. Again let's sync our project. So it has been synced. Now let's rebuild our project again. So it has been rebuilt. So let's now reference our API key. So here let's use this build config. When we place dot, then we have this Unsplash API key. This is how we keep our API key securely in Android projects. Next functionality we will give to that, when we press that image, then it should show the image preview. So for that thing, first let's close this constant file and go to our presentation package. And here in this component package, let's create one file with the name zoomed image card. So how we are going to design that zoomed image card? For that, let's first take a card, attach the modifier to this card. And in this card, we are going to use that async image. So this async image comes with that Coil library. So here first we need to specify the models. So here we can simply use the request we made in that image card. This part, let's copy it and paste it here. So we need to provide this image through the parameters. But for this zoomed image, we are not going to use the small but the regular size. So let's use this image request here. And we can use the modifier with fill max width. This card will be only visible when user will click on that image. Otherwise it will be invisible. So for this thing, we have this animated visibility. So let's use this state here and this card inside this animated visibility. Now we are going to use our zoomed image card in the home screen. So for that, let's go to our home screen. And here in this box layout, first we have this column layout. So first let's minimize this. Then we have this floating action button. And in top of both these, we are going to use our zoomed image card. So here we need to specify these two things. So for these two things, let's create two states here. So first state will be this show image preview and second one will be this active image. So here we will keep the image which user has clicked. Here we will keep the unsplash image and by default it will keep the null value. And let's make our unsplash image nullable. So how we are going to update these two values? First thing, let's attach these two values here. Next thing, in our column layout, we have this images vertical grid. So let's press Ctrl B. Here with the help of this lazy vertical staggered grid, we are showing all those images with the help of this image card. So when user will long press on that image, then we need to detect that gesture and we need to update our image on which user has clicked. So for that, after this clickable modifier, here we have this pointer input modifier and the key we can just provide unit. In this pointer input block, we can detect many gestures. Here we can see we have so many gestures detection. So in our case, we are going to detect drag gestures after long press. This one. So here what parameters we have? We have this on drag start and then we have this on drag cancel and then we have this on drag end and this on drag. So as the name suggests, this on drag start will trigger when drag gesture will start and this cancel and end will trigger whenever this gestures cancel. And here we have this on drag, but this on drag we are not going to use in our app, so we can just provide blank parameters. And for these two things here, let's create two more parameters. So here we will use these two parameters. So here on this on drag start, we let's attach this to on image drag start, and we are going to provide the image on whatever image user has clicked. And in this on drag cancel, let's attach our on image drag end. And in the similar way, let's attach this one also. So for both these things, we will use same parameter. So let's go back to our home screen, and here we have these two parameters. On this on image drag start, we will get the image. So we will update the state of this active image to this image, and also we will update our image preview state to true. And here let's update our image to false. So this is how we are going to update these two states. Now let's run our app and see how this is working. Let's click on any of this image, and here we have our image card. Now next thing, we are going to provide two functionality. One will be that while this image preview is active, then the other screen should be blurred. So the preview image should be more focused. So for this, let's go back to our zoomed image card, and here first thing, let's use a box layout, and here let's use fill max size modifier. And next thing, content alignment to center. So here we will say if this is visible value is true, then we are going to use this cloudy composable, this one, and the content let's use just blank. So this thing, let's open our imports, and here that library we added, this is coming from there. So here we need to specify two things. First one, let's use the fill max size modifier for this also. And next thing, we need to provide the radius. So here radius will be the blurring effect. So we can choose between 0 to 25. So let's choose highest blurring effect, 25. And on top of this blurring composable, let's use our image card. Now let's run our app again. So here let's click on any of these image card. So here we have our beautiful image card with the blurring effect in the background. Let's give some padding all around this image card. Next thing, we need to correct this behaviors. So let's click on the card. So here what is happening? So whenever we click on any of this new image, first it goes to the full screen, then it loads the image, then it actually shows the image at original aspect ratio. So here we need to somehow tell this zoomed image card that it needs to load the image at a fixed ratio. So here it won't go to the full screen first. So for that, first thing, let's go to the home screen, and here let's use padding modifier with 20 dp padding. It will give padding all around that image. And next thing, here we have this function in this request with the name placeholder memory cache. So here what is happening, whenever this image vertical grid is composing, then it is loading the image in the small size. So here it already have the aspect ratio. So we will use the cache of this small image to tell that it needs to use the image cache. So here we can say memory _cache.key. So the key we need to provide that URL. So here we have this image dot image URL small, this one. So it can be null. So in that case we are going to use that blank string. So now it knows that it already has this small image. It will get the aspect ratio from that small image, and then once it will load the big size image, then it will show the bigger size image. Now run it again. Let's click on any of this image. So here we can observe first it loaded the small image, then when it got the bigger image, then it updated that small image with that bigger image, and now we have a beautiful zoomed image card. Next thing, let's give the enter and exit animation. So here in this animated visibility, let's give this enter animation to this scale in with fade in, and the exit animation to scale out with fade out. Next, we also need to provide the image header. So where we will keep photographer's profile image and then the name of that photographer. So let's scroll down, and here in this image card we have this column scope. So here first thing, let's use a row for that header. So here we are using this row layout, and in this row layout we are using this async image for that profile image and this text composable for that photographer's name. Now let's run our app again. So here we have our beautiful zoomed image cards. We can see it will not go away until we lift our finger like this. So first thing, let's minimize this and this also, and close these files. Now let's take an understanding on clean architecture. Clean architecture is a software design philosophy that aims to create scalable, maintainable, and testable code. It separates an application's code into distinct layers, each with a specific responsibility, making the code easier to understand, maintain, and test. In clean architecture, we separate our whole application's code into three layers. Presentation layer, it handles the UI and user interaction. Domain layer, it contains the business logic and rules. It is the core part of the application and is dependent of any other layer. Then we have data layer. It manages data sources and handles user operation. It implements repository interfaces defined in the domain layer. And here in our application, we can see we already have divided our whole application code in these three packages: data, domain, presentation. Now next, let's look at each layer, what components it contains. Presentation layer has components in the form of composables, where we define the UI and handles user interactions. View model, where we use to keep UI states and manage user interactions. Navigation, where we handle navigation between different screens. In our application, we can also see here in this presentation package, we have kept our screens and then view models and the navigation logic. Next, we have domain layer. It has components in the form of models where we keep the core data models that represents the business objects. Repository interfaces where we define the methods for accessing data, providing an abstraction between the domain layer and the data layer. Use cases where we encapsulate the business logic. In our application, we can see we have this domain package and here we have this model package. Here we are keeping our Unsplash image model. Next thing, we will also provide an interface of our repository. Then we have data layer components in the form of remote data sources where we manage network requests, local data sources where we manage local database operations, repository implementation where we provide concrete methods for data operations, mappers where we convert data between different layers. In our application, we can see in our data package, we have kept the remote package where we are keeping the network related code, and we also have these mappers. And in the future videos, well, when we will create that favorites image functionality, then we will also keep the local data source. Now next thing, as we discussed, we need to keep repository interfaces here in the domain model. So let's create a new package with the name repository, and here let's create a new file with the name image repository. It will be of type interface. So here let's define a function, and next let's go to our data package, and here again let's create a new package with the name repository, and here we are going to provide the implementation of this image repository. So here let's extend this image repository and press Ctrl I and implement this. Let's create an object of this Unsplash API service and attach our function here. But again, this is giving the same error that we need to use the mapper function for this. So here let's just use this to domain model list. Now next let's go to our view model in our presentation package. Here in our view model, to get the images from that API service, we are directly accessing this app module, and this is not the good approach. Why? Because this tightly couples the view model to the specific implementation detail of the network service. It also makes it difficult to test the view model in isolation, and the responsibility for fetching images is mixed into the view model, making it less clear and harder to reuse the data fetching logic. So what we are going to do, we are going to provide this function from the outside. So here let's use this inject annotation with constructor keyword. So instead of this, we can simply use this repository dot get editorial feed images. So here we are using this inject keyword. Why? So let's open this and optimize these imports. And this inject keyword is coming from that JavaX. This inject keyword will instruct Hilt to inject the image repository dependencies when creating an instance of this home view model. So how we are going to create the instance of this image repository? Let's go to our DI and this app module, and here create a new function with the name provide image repository. Now whenever this view model will be created, then Hilt will look into this inject annotation, then it will say that it needs to provide this image repository. So it will look into that how it can create that image repository. So we are going to say to the Hilt that he needs to go to this app module, but we need to tell to the Hilt that this is the module it needs to look for the instances. Now we have defined this app module with this annotation. We can see this annotation is coming from the Dagger Hilt. So here in this module, Hilt will come and it will find the function. But we need to tell Hilt that which are the functions it needs to look. So here we need to annotate our functions with the provides annotation. So Hilt will look only those functions which are annotated with this provides annotation. And one more annotation we need to use is singleton. So it will only create one instance of this image repository and it will use in the whole application process only one instance with this singleton annotation. So how it will create? It will take the image repository implementation and it will bind this implementation with this image interface. But this implementation needs the API service because we are using this API service here. So let's go to this and let's pass this API service. So here we can provide this. Now Hilt will ask us that how it can provide this Unsplash API service. Again we need to make a new provide function, so we can tell that this is how you need to provide this API service key. So again let's use another provide function, but this Unsplash API service is going to use that retrofit. So again let's cut this part and use it inside this. And now we can simply just create the Unsplash API service here like this. Let's delete this part. So this is how it will provide the Unsplash API service to this function. We have defined it here. Next thing, we also need to annotate our app module with one more annotation install in singleton component. Next, one more thing, when we look into our view model, so here we are using this inject annotation with constructor keyword. But when we go to this image repository implementation, here we are not using any such thing. Why? This is because the repository implementation typically implements an interface. So Hilt is aware of this interface and knows that when an instance of this interface is required, it should provide an instance of the implementation class with the required dependencies. We can also see here this is the case. Next, we need to use some more annotations for Hilt to generate the required code. First thing, let's go to our view model and here we need to annotate all our view models with this Hilt view model annotation. Next, let's go to our main activity and here we need to use Android entry point. The Android entry point annotation is used to annotate Android components such as activities, fragments, services and broadcast receivers. Next, in our presentation package, let's create one more file with the name image Vista application and let's extend with this application class. And here we need to annotate with this Hilt Android app. So when we annotate application class with Hilt Android app, Hilt generates necessary components for the application. This setup is necessary for Hilt to handle dependency injection throughout the entire application. Next, we need to define that we have an application class in our manifest file also. So here let's use this name and presentation dot image vista app. And one more thing, let's go to our nav graph Since we are using the Dagger Hilt automatically provide this view model instance. So we just need to use this view model of type home view model, and here it will just provide this view model like this. Now let's close this file and this file also. Now let's rebuild our project so we can make sure that everything is working fine. Our cradle has been built successfully. So this was all for the dependency injection. In the next video, we will design our full image screen. If you found these videos helpful, please like the video and subscribe to the channel. Thanks for watching.